This video is just looking at updated phenology files since more people are trying to use them. So for now, of course, it's still all in MATLAB, but I think you're mostly used to that at this point. So these are all saved as templates in just the csync root here. So they're all going to be down here. So we'll have pheno user config file, pheno control file, which is for running and viewing individual points, need a stack pheno, and then I'm also going to save one more file which you can do cross-validated classification based on phenology, the phenology curves themselves, just for points for now in order to do your calibration and validation of 4 classifiers. So I'll show that. So for starters, on the left here is the updated user config file. So the main update is that this is now can be used for Sentinel-2 also, or Landsat. So you need to make sure that your sensor is specified correctly here. I've just put in a little more documentation. I won't go into detail here. Date ranges is everything else is basically the same, just better documented. So move that down for now. And then this is the pheno control file. So I'm going to run Hannah's Sentinel-2 data and just mind the things that say user entry, because that's where you definitely have to do something. So I'll run that and read in her table. So you can see here's the object IDs and the names for your reference. You can always, if you need to, come back to this line and just run this code to see that table again. And then this is where you run your individual, what are they called? Individual pixels. Yeah, so just control enter in there. And this is her 3 date ranges for object ID, and just do one more like that. And remembering that it goes from blue to cold colors to warm colors, so kind of like the rainbow. So cyan, or blue, cyan, green, yellow, red, magenta, and that is specified in the user config file for your reference. Oh wait, it's also specified right here. So that's it. That's it for this file. This is just for viewing those individual curves. Get rid of that for right now. So the new file is a classifier, and it's not an image classifier. It's just for after you gather a bunch of sample points for each of your land cover classes, for example, you can see how phenology helps in separability. So clear this out. So I'm going to run this on a data set that I have where I collected 4 classes in a place in Alaska, where I could tell whether they were broadleaf deciduous, needleleaf, evergreen, it was open, or it was a mix. So some of those classes are pretty easy based on phenology, and some are more difficult. Mixed, obviously, is going to be difficult. So here, the user entry is the same thing. You put your table in and put in your user config file up here, remembering to set your directory. That guy. And you can see here's my table of open, mixed, conifer, broadleaf, etc. And so this now, 1.4, which really doesn't need to be 1.4 anymore, that's very old, vestigial, but we'll loop through all of your object IDs. So in this case, I have 68 points. And it will grab the phenology values that are created with the spline or fourth degree polynomial interpolation and put them into a table format. So it makes 2 tables of pheno dates and pheno values. And so if you wanted to, once you run this loop, you could just save those off as a CSV or something and do more sophisticated analysis elsewhere. But I have included a simple canonical discriminant classifier that's easy to run here to get a quick look. You're only going to do this on one date range at a time. So your date ranges, recall, are specified in here. So there's 3 date ranges in this file, but this isn't actually the user configuration file that I'm looking at right now. So that's not that helpful. So in this one, I only have one date range for the moment, which is fine. I also had 3 at one point. So I just want to specify somewhere between 1 and the number of date ranges you have, so presumably no more than 6. And I think that's all you need to do, and then just Control Enter in there. And so just for the purposes of showing you what this is doing, oops. So what I'm showing here is the pheno dates matrix, meaning, actually, probably more interesting to look at the values. All right, so this is a 68 by 37 matrix, and so the 37 is just 1 to day of year 365, but with 10-day resolution. And then this is 1 to 68, my number of observations, and then so you're seeing the actual phenological values here through time. So not surprisingly, the highest values are in the middle of the summer. So then I can, if I want to, do a very simple, rough classification. Just goes through and gets rid of places where there's just no data at all. Like for me, it's before day of year 100. This is Alaska. And then it will run a canonical discriminant analysis classifier in a cross-validation mode. So it runs it 100 times in this case, each time using 70% of the data set for calibration and 30% for held out validation. So I'll just run that. And so it outputs a few things, but the most important are the overall accuracy. So this is 79% overall accuracy, which is okay, given some of my classes are pretty confusing. And this is my confusion matrix, which is going to line up with my 4 classes of broadleaf. So broadleaf, coniferous, mixed, and open. And you can get derive the other like users and producers accuracy from this downstream. So that's it for now, and give it a shot if you want to.